Okay, so in this video, we're going to go over reaction stoichiometry. In the previous unit we've done compound stoichiometry. So the difference between reaction and compound is that in compound, we start with a substance, we remain with that same substance the entire time. In reaction, we're actually looking at how a substance goes through a chemical reaction and turns into something else. So in reaction stoichiometry, we're going to be switching substances from substance A or substance B, or from what you're given to what it's asking you to solve for, by using the coefficients from the balanced equation as a bridge, as a method to swap substances. And we call this the mole bridge. And in order to use the mole bridge, or the ratio of the coefficients from the balanced equation, you have to be in moles of substance A. Just like what we saw in compound stoichiometry, you always have to set up your equations so that your units cancel. And in order for the units to cancel appropriately in the mole bridge, you have to be in moles to begin with. So the mole bridge is the only place the coefficients from the balanced equations come into play. And everywhere else, we're essentially just doing what we did with compound stoichiometry. So this is just compound really plus a step. So we don't have a mole highway like we did in the previous unit, but we can make a little like map. So substance A is whatever number and substance you're given. And it can be in particles, it can be in mass, it can be in liters, it can also be in moles. But if you are in any of the particles, atoms, molecules, or formula units, mass, or liters, the very first step you have to do is convert to moles. Because again, in order for the units to cancel appropriately, you have to be in moles before you go into this mole bridge step. So if you are in any of these things, you're going to do the compound stoichiometry steps that allow you to get to moles. Because from here to here, we're staying in the same substance. So it's essentially just compound stoichiometry. Once you're in moles, you're going to go to your balanced equation. You're going to look at the coefficients that you have. You're going to put the coefficient in front of the word mole of the substance that you're going to on top. You're going to put the coefficient next to the mole of the substance that you're getting rid of on the bottom. Once you've done that, that's going to allow the moles here and the moles here to cancel. And now you're into your new substance. From that point, it just becomes compound stoichiometry again. You're into moles of B. You're going to convert out to whatever units the question requests the answer in, whether that be particles, mass, or liters. If it's moles, you're done. But most of the time, it's going to be going to something else. So really what we have is some compound stoichiometry, the mole bridge step, some compound stoichiometry. It's only this middle step that we're doing that's anything new. Everything else is what we just finished doing in compound. So in reaction stoich, your first step is always to convert from the units that you're given initially into moles. And then the second step is always going to be the mole bridge. If you're already in moles, then obviously we go straight into the mole bridge. Okay. So let's look at some examples. Our first example, how many liters of CO2 are produced if 75 liters of CO are burned in O2? So you're getting a little bit of context in the question, but don't lose sight of the fact that you're only given one number and asked for one thing. So you're given to start with 75 liters of CO, that's my A, and you're asked for liters of CO2. CO2 is my B. It tells me it's burning it in O2. That's just giving me some context. I don't really care about the O2. I'm not calculating anything with it. So our first step before we do anything else is to balance our equation. So I'm going to go through the balancing portion rather quickly. This is not a video about how to balance equations. We already know how to do this. So if you need to review how to balance equation, go back to the balancing equations video from 2 units ago. So first thing I need to do, diatomics, and then add my coefficients. So I've got 3 oxygens on the left, only 2 on the right. I'm going to put a 2 here. That's going to give me 4, a 2 here, 2C40. Okay. So I'm always going to start with the number and the substance that is given and start to work through my steps of our stoichiometry here. So 75 liters CO times. I'm not in moles, so my very first step is to go to moles. 1 mole CO over 22.4 liters CO. That gets me out of liters and into moles. Now I'm going to do my one new step, and I'm going to do this in a different color pen just so you can see the step. So I'm getting rid of moles of CO. So moles of CO go on the bottom. I go to the balanced equation. I'm going to pick up my coefficient for CO, which is 2. It's asking me to solve for CO2. So I need to convert to moles of CO2. I go to my balanced equation. I pick up my coefficient. This part is the only time where I care what these coefficients are. The rest of the time, I don't care. So my moles of CO are going to cancel. And then I have moles of CO2. I need to look at what unit it asks me to solve for, liters of CO2. So I'm going to convert 22.4 liters CO2 over 1 mole CO2. My moles of CO2 cancel. It's going to leave me in liters. Now, some things to think about in this particular unit. When I'm going to put this into my calculator, the easiest way to do it is to take everything on the top, multiply it across, get an answer, and then divide that by everything on the bottom times each other in parentheses. But the less that I type into this thing, the better, right? The more that goes in, the more I'm inviting some dumb calculator mistake. So if I can look at my equation and see where I can get rid of some math, that benefits me. Okay, you may not want to do this. You may want to type everything that's written, but I find it helpful. So for example, when I look at the fact that this is 2 over 2, right? 2 over 2 is 1. Why am I going to multiply by 2 and then turn around and divide by 2? I'm going to get the same thing. So I can actually leave this step out entirely. I can also look at these two conversions. Same idea. I'm going to multiply by 22.4, then turn around and divide by 22.4. That's extra, right? So I'm getting rid of that. So really, I don't have any math to do here. Now, this is not going to work out like this every time, but once in a while, you'll see that you'll be able to cancel everything. So 75 liters of CO is going to give me 75 liters of CO2. Now, I could also go through and type all that into my calculator, right? So 75 times 2 times 22.4 divided by 22.4 times 2. Still 75, okay? It's not voodoo math. So what did I see here? I started with liters of CO. I converted to moles of CO. I did my mole bridge step. That got me from moles of CO into moles of CO2. Then I converted to liters of CO2. And that's what the question asked for. All right, so let's go on to the next one. If 3.4 times 10 to the 23rd atoms of H2 are produced by decomposing water, how many molecules of O2 are also produced? So again, what am I given? I'm given atoms of H2. What am I asked for? Molecules of O2. It mentions water, but I don't really care. These are the only two parts I need. Now, I do need to balance my equation, so let's look at that. I've got a diatomic hydrogen and a diatomic oxygen. So 2 hydrogen, 2 hydrogen, 1 oxygen, 2 oxygen. So if I put a 2 here, that gives me my 2 oxygens. That's going to give me 4 hydrogens, so 2 here. All right, so now I'm balanced. All right, so starting with the number given, 3.4 times 10 to the 23rd atoms, H2, times, I need to go to moles of H2. So 1 mole H2 over 6.02 times 10 to the 23rd atoms, H2. That gets me out of atoms, puts me in moles. Now I need to do my mole bridge. I'm getting rid of the moles of H2, so that goes on the bottom, and I'm going to moles of O2. That goes on the top. So look at my coefficients. I don't have a number in front of the O, so I know that means that there's only 1. And then I have a 2 in front of the H2, so that goes there. So it gets me out of moles of H2. I'm into moles of O2. The question wants my answer in molecules. So I'm going to convert to molecules. 6.02 times 10 to the 23rd molecules. O2 over 1 mole. O2. Moles cancel. It's going to leave me in molecules. Okay? So in terms of making my math easier, again, be observant. I'm going to both multiply and divide by 6.02 times 10 to the 23rd. If I can get rid of that behemoth of a number, I'm going to do it. So now really what am I doing? I'm taking my 3.4 times 10 to the 23rd and I'm dividing by 2. Okay. So 3.4 times 10 to the 23rd divided by 2, 1.7 times 10 to the 23rd. 1.7 times 10 to the 23rd molecules. O2. Remember that at each step, you should have number, unit, substance, number, unit, substance. If you will do that, you're going to be less likely to make a mistake by putting one of your conversion factors or part of your mole bridge in the wrong place. All right, let's go down to number 3. How many grams of KClO3 are produced when 25 grams of KCl reacts with oxygen? So I'm starting with 25 grams of KCl, and I'm solving for grams of KClO3. I need to balance my equation, so I'm going to start with the diatomic on the oxygen. I've got 2 here, I've got 3 there, odd and even problem. I'm going to put a 2 here, now I have 6, 2K, 2Cl, 2 there. Okay. Now this time, because I'm in grams, remember that means that my conversion factor I'm going to need is molar mass. Be very careful when you're adding up your molar mass here, because if you mess up the molar mass and you have 2 of them, you're going to get the problem wrong. Okay. So let's do the KCl first. So potassium is 39.10 plus chlorine 35.45, 74.55. And then the KClO3 is just this plus 3 oxygens. So plus 3 times 16.00, 122.55. All right, so let's start setting up our problem. I'm starting with 25 grams of KCl. First step, go to moles. 1 mole KCl over the molar mass of KCl, 74.55 grams of KCl. That gets me out of grams and into moles, moles of KCl. I need to go from moles of KCl to moles of KClO3. So I've got 2 moles of KCl and 2 moles of KClO3. 2 moles KClO3 over 2 moles KCl. The moles of KCl are going to cancel. Now I'm in moles of KClO3. I need to go to grams. That's why I got the molar mass. Times 122.55 grams KClO3 over 1 mole KClO3. Moles cancel. It's going to leave me in grams. Now, how can I make this easier for myself? 2 over 2 is 1, so let's get rid of that. And so now what I'm going to do, 25 times 122.55 divided by 74.55. All right, 41.096. I can have 2 sig figs, so 41.096 is going to be 41 grams of KClO3. All right, let's go on to our next one. What volume of NH3 is produced if 75.0 grams of nitrogen reacts with excess hydrogen? So I'm starting with grams of nitrogen, and I'm solving for volume of NH3, which is ammonia. So I need to balance my equation. So diatomic here, diatomic here. I've got 3 and 2, so I'm going to put a 2 here. That's going to give me 6, a 3 there, and that also fixes the nitrogen. Okay, so I've got grams of nitrogen, so I will need the molar mass of nitrogen. Remember that nitrogen's diatomic, So the 14.01 is going to be doubled, and that's going to give me 28.02 as my molar mass. And then I'm going to do volume, which I know is a constant. So 75.0 grams N2 times 1 mole N2 over 28.02 grams N2 gets me out of grams into moles. Now I need to go through my mole bridge. So I'm going to NH3, so 2 moles NH3 on top over 1 mole N2 on the bottom. That gets me out of moles of N2 and into moles of NH3. And then it wants me to go to volume. So times 22.4 liters NH3 over 1 mole NH3. Moles are going to cancel. It's going to leave me in liters. Nothing here I can cancel out, so I'm going to have to use all of it. So 75.0 times 2 times 22.4 divided by 28.02. And that gives me 119.91. I can have 3 sig figs, so 119.91 is going to round. This is going to be 120 with a decimal because I need the 3 sig figs, liters NH3. All right, so we've done 4 examples. I do have a couple more, but what you should have noticed by this point is that you're doing the same thing every time, right? Whatever unit I'm in to begin with, the very first thing I do is I go to moles of that substance. Then I go through the mole bridge every time. And then I just convert out to whatever whatever units are requested as my answer. It's the same steps every time. If you're not in moles, go to moles, then mole bridge, then convert out to whatever it's asking for. All right, so let's go to our next example. How many liters of nitrogen are needed to react with 6 moles of hydrogen? So I'm starting with 6 moles of hydrogen, and I'm solving for liters of nitrogen. All right, I need to balance my equation. So diatomic here, 2 here, 2 times 3 is 6, 3 here. All right, so we're good. Now, notice what they're giving me to start this time. They're giving me moles. So I don't have to go to moles, I'm already in moles. 6 moles of H2 times, that means my very first step is going to be mole bridge because I'm already in moles. I'm trying to go to nitrogen, so that means my nitrogen has to go on top. 1 mole N2 over, I'm getting rid of hydrogen, 3 moles H2. All right, so my moles are going to cancel. And then it asks for liters. So times 22.4 liters N2 over 1 mole N2. All right, so let's look at our math. 6 times 22.4 divided by 3, 44.8. All right, so let's consider our sig figs. 6 has 1. So that means 4, this isn't going to round, so 40 liters N2 is my answer. Okay. All right, so we have 2 more. Next one. If 5 grams of KClO3 are decomposed, how many molecules of oxygen are produced? So I'm starting with 5 grams KClO3, and I'm solving for molecules of oxygen. I need to balance our equation. So diatomic here. I've got 2 and 3, so I need to head to 6. There's 2 here, a 2 here, and a 3 here. Okay. 5 grams of KClO3. So I'm going to need a molar mass. Now, we've already done this molar mass, 122.55. We did it on that previous problem, so we don't have to recalculate it, which is nice. So we're going to start setting it up. 5.0 grams KClO3 times 1 mole KClO3 over 122.55 grams KClO3. Grams of KClO3 cancel. Now I'm in moles. Now I'm going to mole bridge to oxygen. So 3 moles O2 over 2 moles KClO3. And then it wants the answer in molecules times 6.02 times 10 to the 23rd molecules O2 over 1 mole O2. Okay, so nothing I can get rid of here, nothing I can simplify. Notice that I do have 2 things on the bottom. You need to be very careful when you do have 2 things on the bottom to make sure that those are going in parentheses together when you divide. If you don't, what your calculator is going to do is divide by the first thing and multiply by the second thing. And in this case, you would get double what you should. So let's practice putting this in. 5.0 times 3 times 6.02 times 10 to the 23rd. Go ahead and get an answer. Divided by parentheses, what was my mass? 122.55 times 2. And what do I get? 3.684 times 10 to the 22nd. So how many sig figs can I keep? I can have 2. So 3.68, that's going to be 3.7. 3.7 times 10 to the 22nd. Molecules, O2. All right, so last one. If 54.3 liters of CO2 are produced in the following reaction, what volumes of CO and O2 are required? Volumes, that's plural. So that means that this question wants me to solve not only for the volume of CO, but the volume of O2 as well. Do I do anything different? No, I just do 2 separate problems. Both of them are going to start with the same number that is given, and I'm just going to do 2 problems. Basically, it wants to know is, well, what did I need of this one and that one that allowed me to get this much of the CO2? Okay, so let's balance our equation. Diatomic 2, I've got 3, so let's put a 2 here and a 2 here. All right, so I'm just going to do 2 equations. Both of them are going to start with the same beginning number. So 54.3 liters of CO2 times 1 mole CO2 over 22.4 liters CO2. And let's see, for the first one, let's go to CO. So times 2 moles CO over 2 moles CO2. And it wants me to go to volume times 22.4 liters CO over 1 mole CO. Well, let's see. 2 over 2 is 1, and both multiplying and dividing by 22.4 is going to be the same. So 54.3 liters of CO is how much CO was required. And let's do the O2 now. So same thing. Starting with the same beginning number, 54.3 liters of CO2 times 1 mole CO2 over 22.4 liters CO2 times, now this time we're going to O2, so 1 mole O2 over 2 moles CO2, so out of liters, out of moles, into moles of O2 times 22.4 liters O2 over 1 mole O2. All right, so what happens this time? Well, the 22.4 and the 22.4 still cancel, but this does not cancel. So I'm going to take my 54.3 and divide by 2. 27.15 to 3 sig figs, that's going to be 27.2 liters O2. Okay, you're going to follow those same procedures every time, all right? Whatever you're in, go to moles, mole bridge, convert out.